Imagine a computer so powerful that it could solve problems in seconds, problems that would stump even the fastest machines we have today. These are problems that would take a normal computer, well, billions of years to crack, if they could solve them at all. This isn't science fiction, it's actually the promise of quantum computing, a technology that could change everything about how we process information. Quantum computers are a completely new type of computer, unlike anything we've built before. They use the bizarre and counterintuitive rules of quantum mechanics to store and process information in ways that seem almost magical. Quantum mechanics is the study of how tiny particles behave, particles so small we can't even see them with a regular microscope. And at these tiny scales, the universe gets very strange. Particles can be in two places at once, or even seem to communicate instantly across distances. Normal computers use bits, which are like tiny switches that can be either on or off, representing 1 or 0. Quantum computers use qubits, which are much weirder and more powerful. Qubits can be 1, 0, or both at the same time, thanks to a phenomenon called superposition. This both at the same time state is what makes quantum computers so powerful, allowing them to explore many solutions at once. By harnessing these quantum effects, we can potentially solve problems that are impossible for even the most powerful classical computers, opening up a whole new world of possibilities for science, medicine, and technology. To understand quantum computers, we need to take a trip into the weird and wonderful world of quantum mechanics, a place where our everyday logic simply doesn't apply. The quantum world is the world of atoms and the particles within them, a realm so tiny that it's invisible to the naked eye and behaves in ways that seem impossible. Here, the rules of physics, the rules we are familiar with in our daily lives, break down and are replaced by a new set of bizarre principles. One of the strangest things about the quantum world is that particles can act like waves, blurring the line between what we think of as solid objects and energy. Imagine a tiny marble rolling towards two slits. In the normal world, it goes through one slit or the other, just as you'd expect from any small object. But in the quantum world, the marble acts like a wave, going through both slits at the same time. This is called superposition, and it's one of the key ideas behind quantum computing. Another strange phenomenon is entanglement, where two particles become mysteriously linked, no matter how far apart they are. Imagine two of our marbles. They are linked somehow so that whatever happens to one instantly affects the other. If one is spinning clockwise, we know instantly the other must be spinning anti-clockwise, even if they're separated by a huge distance. This link, this entanglement, holds even if the marbles are light years apart. It's as if the universe itself is playing by a different set of rules, rules that are both strange and wonderful. Quantum computers take advantage of these strange quantum effects. They use qubits, which can be in a superposition, like our wave marble, being 0 and 1 at the same time. This is unlike a bit in your phone or laptop, which can only be either a 0 or a 1. Think of a coin spinning in the air. It's not heads, it's not tails, it's both at the same time. That's superposition. When we measure the qubit, forcing the coin to land, it becomes either a 0 or a 1. Entanglement lets us link qubits together. Imagine 100 spinning coins all linked. Changing one instantly changes the others in predictable ways. This interconnectedness gives quantum computers their immense power. What could we do with such powerful machines? The possibilities are honestly just breathtaking. One area is cryptography. Modern encryption relies on complex mathematical problems that are, well, pretty difficult for classical computers to solve. Quantum computers could crack these codes in a flash, revolutionizing security and privacy. Drug discovery is another exciting area. Quantum computers could simulate molecules with incredible accuracy. This could lead to the development of new drugs and treatments for diseases. The power of quantum computers also extends to materials science. By simulating materials at the atomic level, we could discover new materials with incredible properties, paving the way for technological leaps in energy, transportation, and more. So, why don't we have quantum computers on our desks yet? Because building them is, honestly, incredibly difficult. One of the biggest challenges is decoherence. Remember our spinning coin? The slightest disturbance from the outside world, like a vibration or a change in temperature, can cause it to collapse to heads or tails too soon. This loss of superposition, called decoherence, causes errors in calculations. Building quantum computers that are large and stable enough to be useful is a huge engineering challenge, requiring extremely cold temperatures and perfect isolation to protect the delicate qubits. The idea of quantum computing emerged in the 1980s. Physicist Paul Benioff is credited with first describing a quantum mechanical model of a computer. Richard Feynman, famous for his work on quantum electrodynamics, later argued that quantum computers could simulate complex quantum systems, something classical computers really struggled with. A major breakthrough came in 1994 when Peter Shor developed a quantum algorithm that could factor large numbers exponentially faster than any known classical algorithm. This discovery ignited the field, as factoring large numbers is the basis of many encryption methods. Since then, progress has been rapid. Companies like Google, IBM, and Microsoft, along with numerous startups and universities, are racing to build practical quantum computers. We are still in the early days of quantum computing. The technology is just beginning to emerge from the realm of theory and into practical experimentation, and the journey ahead is both challenging and thrilling. The quantum computers we have today are experimental and, honestly, prone to errors. They require extremely controlled environments and are sensitive to even the slightest disturbances, making them difficult to operate reliably. But the progress made in recent years is undeniable. Researchers around the world are making breakthroughs at a rapid pace, pushing the boundaries of what's possible. In 2019, Google claimed to have achieved quantum supremacy with their 53-qubit Sycamore processor, a landmark moment in the field. This meant that it performed a specific calculation faster than any classical computer could, demonstrating the unique power of quantum technology. While this was a significant milestone, it was only a small step towards building truly useful quantum computers. There is still a long way to go before these machines can solve real-world problems. The future of quantum computing is brimming with possibilities. As the technology matures, it could transform industries and change the way we approach complex challenges. It has the potential to revolutionize medicine, materials science, artificial intelligence, and many other fields, unlocking solutions that were once thought impossible. And while there are significant challenges ahead, the quest to build these powerful machines is one of the most exciting scientific endeavors of our time. The next chapter in computing is just beginning.